calculating, again, boys, the mean, median, mode, and range. So I started the video late. Go ahead and look at the mean, which is like you're adding grades, dividing by how many grades. The median, the one in the middle, when you line them up from least to greatest. The mode is the one that appears the most, and the range. And then these are the two that we did. Make sure you show your work on how you got all of them. Show it on another sheet of paper. And if you are watching this at home, you can stop the recording and you can see how we did the number 6. Alrighty, so let's go on the inside. We're almost done, actually. So this actually came from Fred. This actually came from this is in chapter, I think, 9. No, it's chapter 8. The one we just did was 8-2. This is 8-1, but it is super easy. It says, of 200 radio controlled cars that were manufactured by one company, 3 were defective. So are those two things that go together?
Yes, that's a ratio.
It's a ratio. So let's write it. It's 3 are defective out of the 200 that they're testing. So that's your total.
Are those radio controlled? Those are RC. Okay.
Yeah. So anyway, it doesn't matter. Anyway, girls and boys, it says the company manufactures this many each day. About how many defective cars would you predict are going to be produced? What would we have to put over here?
Variable on top and a dollar.
So, well, we're talking about how many are going to be defective. So I'm going to put a D over how many cars are being made each day.
1,000
is 1,000. So we do this just like we've been doing. Ratio and proportion. What would I multiply the 200 times?
5
Times 5 times 5. How come it's going to be 15? I need you to show the work and put it down, because if there's no work, there's no credit.
Which one was this?
It's right here, the number 9.
It's not.
All right.
Thank you.
So on this one, same thing. It says, of 12 customers at one restaurant, 10 said that they were very satisfied. Do we have a ratio?
Yeah.
What are we going to put, 12 over 10 or 10 over 12?
12 over 10. 10 over 12. Oh, wait.
10 out of the total of 12. So 10 out of the 12 said they were very satisfied. So that's out of my sampling. So I sampled this many people. Well, predict how many people would be satisfied if there were 300 people at the restaurant. Where would I put the 300?
Top.
Does it say 300 are satisfied?
Bottom.
That's it. That they're not saying that those are satisfied. That's the total of people that I had in my restaurant, and we're seeing how many of them are very satisfied. So I'm just going to have to divide this, or can I reduce that? Yeah, I can reduce this. So reduce this down to 5 over 6, and then does 6 go into 30?
Yes.
So 6 times what will give us 300? 6 times
50.
50.
I got
Okay. So 6 times 50 is 300. 5 times 50 is 250. We can expect would be very satisfied. And then going down, we're going to look at this chart here. This is a frequency table where they have tallied everybody's response of what means of transportation do you use to get to work. And this is car, this is a bus, train, bicycle, and walk. And so the frequency is the actual number when they counted that. And this here, cumulative frequency, is they added as they went. So this was 15, this is 24. Together, that's 39. And then the cumulative frequency on the next one, now they add the 10 and so on. So our overall total is 60. They tallied 60 people. Then it says, we're going to make another prediction. Predict how many bike rack spaces are needed for 750 warehouse worker. Well, what would you look at on the chart? What are we looking for? People that ride the what?
Bike.
How many ride the bike?
5.
Out of what? So that's our original. So 5 people ride the bike out of the total of 60. And we want to predict how many bike racks will be needed for 750 people. Where would I put the 750? On the bottom.
Sure.
Yes.
I don't get the.
The cumulative is, they're just adding these as you go. 15 to 24 is 39. Then the next group of train is 10, so 39 and 10 is 49. Then we're at 49, we're just adding.
10 and 49 is 54.
And adding the 5, it's 54. Okay. All right, then, so this one, I could reduce it. I think I'm going to have to end up dividing anyway, so I'm going to see if 60 goes into 750.
I mean, it's more of a question, can 12 go to 750?
It doesn't matter either way. So 1, that's 60, that is, I don't think it's going to go perfectly. So that's going to be 2, 30 over 60. So it's going to be 12 point what? 12.5. So it's going to be, this is times 12.5? Or did 12 go into it perfectly?
I don't know.
So times 12.5, and this times 12.5.
Wait, why did you just have to? What?
How did I get what?
Because 60 you can go into 750 12.5 times. No. 60.
I used 60 here to see how many 60s were in that.
That's the total of all of them.
Okay, we need to go on, explain to her later. So again, we had 5 people riding the bike out of a total of 60.
22.5.
And so this is going to be 1, 2, 5 times 5. That's 10, 11, 12. And that's going to be 5, 6. So is that right? Guys, you need to show your work also. So we need, and you can't have this many, so we need about 63 bike racks.
Why did you times 5?
It's 62.
Because it's 12.5 times 5. 12.5 times 60 is 750. So 12.5 times 5 is my answer. And you can, but you don't have to. All right, and then this one, same thing. It says, in the survey of all those who use a car, 12 drive alone. The others carpool. All right, out of 750 employees, predict the number that carpool. So let's go back to the cars. So they said out of this number, in the survey of those who use a car, 12 drive alone. So if 12 drive alone, how many carpool?
3.
Yeah, I'm going to subtract the 12, and that would be 3. So the number that carpool is 3 out of the what again? What's my total?
60.
Is out of the 60. 3 out of all those people carpool. That's out of my total. And Charlie, you get this down also? And then so out of 750 employees, how many can I predict will carpool? Where would I put the 750?
Bottom.
Is it 12.5?
Is 750. Well, isn't that the same number we just got?
Yeah.
So we can just, it's going to be 12.5 again. So times 12.5 times 12.5. So that's going to be 3 times 5 is 15. 3 times 2 is 6 plus 1 is 7.
75.
And 3 times 37.5. So, and again, you can't have 37 and a half people. So we're going to say about 38. Okay. That's pretty easy. All right. Then, let me look at our time.
That's the total.
People voted.
You guys get out of here at what time? 2:30? Okay. So, let's go ahead and flip it over to this side. We have about 25 minutes. So, we're not going to do all of these. We're going to do some of them. I'm trying to find some of the easier ones that you're going to do.
2.
Okay, guys, hold on. Be quiet for a second.
Oh, that's a total number.
So,
That's what I'm saying.
That's what I'm saying.
Didn't have to go.
all right, Christian. All right, so here we go. The ones that you're going to do is we're going to do one time you're going to find the average of just D. So watch carefully. I'm circling the ones that you need to do. You're going to find the average of Dean scores. So I would have to do what?
Add them all up.
Add up Dean scores and then divide by what? How many tests did he take? Divide by 4. You're also going to find the average of test 1. So now the test 1, you're going up and down. So you're going to add those and divide by how many people were taking the test. 1, 2, 3, 4, 5, 6, 7. So that's one of them. Then, okay. Christian, be quiet, please. So then go down and, okay. Oh, this is a good one. Then you're going to go down and go to number 5. You're going to look at this chart and it says, find the following. The average earnings per month. So here's the earnings. What would you have to do?
Add them up and divide.
Add them up and divide by how many months?
5.
By 1, 2, 3, 4, 5. Because they want the average per month. So that it's earnings per month. The other one is find the average time worked per month. Find the average time. Here's time. What would you have to do on that one?
Add them all up and divide.
Add them all up and divide by what?
5.
By 5, because it's also the average time. You don't have to do the C. So just do this one and this one.
Got it?
But I do want you to do this one because this is important. On this one, you need to use this formula of distance is equal to rate, which is how far he runs, times the time. And so I'm going to leave this for you. He ran a marathon of 26.219. Where do you think I would put that distance? Would I put it in the D, in the R, or in the T? That would be the distance. And then he ran for an average of 5.5
minutes and 47 seconds.
minutes for each mile. So then you're going to be asking,
Do you pass out these in 6th grade
yeah, but I
before
have,
they go home?
Yeah.
It's only those kids that are getting it. It's just the band kids.
Oh,
Nobody
okay.
else is getting one.
oh, okay, that's, yeah, I sure do. Thank you, ma'am. Okay. Well, in fact, let's go ahead and do this one. Let's do this one. So on this one, it says, so it's distance equals rate times time. So we're looking for how many minutes did it take. So that's probably going to be left over. So the distance is 26.219. And what was his rate? How fast did he run? Well, if you don't know, you don't need to say anything. But you need to read your paper. So does it say right here how fast he's running?
Yeah. It was 5 minutes.
It's 5.27 minutes for each mile. How many minutes did it take him? So I don't know how many minutes. So, and they want you to round to the nearest tenth. So how do I solve that? Yeah, because I want to get the minutes. So I'm dividing by 5.27. We're dividing by 5.27. No. So I'm going to set it up. By the way, how many places to make this easier should I move the decimal? So I'm going to move it over 1, 2, and I can do the same thing up here, 1, 2. So it's going to be the top guy goes inside. So it's going to be 2621.9 divided by 527. We can do this and bring this straight up. 500 does not go into 2. 500 does not go into 26. 500 does not go into 262. 500 does go into this. So who wants to guess? And I'm going to cover this up. I'm going to cover one up. About how many 50s are in 250? Probably about 5. So I'm going to go over to the side and go 527 times 5. So that's going to be 35. That's going to be 10, 13. And that's going to be, oh, don't tell me it doesn't go in. It's not. So it's not going to be 5. It is going to be what?
4.
It has to be 4. Fred, be quiet. Right. So this was a hard one. So it's 2108. So that's 12 to get to 20, and one more, that's going to be 13. Okay. Bring this down. Okay. And then, let's look at this one. If I covered one number up and one number up, if that were a 52, it would go 10. But we can't put a 10 on top. Who knows the biggest number it's going to be? It's probably 9. And I'm going to guess it is 9. So 527 times 9. And that's going to be 18, 19, 20, 21, 22, 23, 24, 45. And that is going to work.
Which problem do you have to do or one?
Hold on just a second. All right. Okay, so here is my remainder. I don't want to take it out anymore. But is this number even close to 527?
No.
No, it's so far away, we don't have enough to round it up. You probably should see 4.9 minutes. Do you see a 4.9?
I think it's that's crazy. Wait, can you go back?
No.
I see 4.9. God.
Oh, they rounded, oh yeah, it's saying they rounded it to the nearest hundredth, and I didn't round it enough. So it's okay, we're done. I just wanted you to use this formula. So it is 4.95, and let's stop right there. This is minutes. Oh, this one is dollars. So hold on a second, 4.9.
It's not on there.
I don't see it. How many minutes? Hold on a second.
Oh, no, it's not on.
So now is when I'm going to break out the calculator. So it's
Oh, I think those are those the hours?
26 point.
I think you have.
Well, it's coming out to be actually,
4.975. So we got it right.
we do have it right. So don't worry about it, guys. Don't worry about it. Let's just go ahead and put our number here. It's
Yeah,
about,
it's here. It says 4.95 though.
is there a 4.9?
No, that's dollars.
That's dollars.
Oh.
That's money. So I don't know where it is because this is minutes. And I don't see anything with minutes. But anyway, 4.9, but just put that. All right. I just wanted you to know how to use that formula. So girls and boys, all you have to do, let me see what time it is. All right, you've got about, so I'm actually going to change this. So we're going to wrap this up. You've got this one to do, this one to do, and I think I'm going to change it to say, okay, no, I'm going to take this one off and just do A, D, and F. That's it. Turn it in.
Let's go.
Let's go.
Back.
Let's go.